All right, and this is Sam Welker with thinkparticle.com, and in this video we're going to be talking about something special. This is a unique tutorial for our blog because this is the first time I believe that we're actually going to jump into Houdini. I might have posted something before, I'm not sure if I ever posted it, but anyways, we're going to be talking about doing some custom particles in Houdini. This is a big mess of particles. It looks pretty cool, but anyways, what we're going to do is be creating this this vortex of particles. So this is actually like a really close-up shot with some depth of field on some particles in Houdini that swirl. So let's go ahead and just take a look at these particles before we get started. So what you may notice is that there's a lot of them. If we actually hold the middle mouse button down, you can see that in 2 seconds in we've already got 500,000 particles. So it's not that many for some renders, but if you aren't used to doing particles, that's a lot of points. So this is quite a lot of fun to create, and we have this like swirly motion right here around the spline that goes up, which we can see here, and I'll show you how to make that. And basically it comes off of this little this circle right here, and it's emitted through the popnet with some custom forces. We use a couple of, let's go back to the beginning. Here we go. We use a couple of different pop or particle operator tools. Actually skip that one. And then we use wind forces, and we end with a vortex force. And I'll show you how we actually use the attributes in Houdini to create the radius tapering off at the end. So anyways, this is going to be a lot of fun, very powerful rig. And I'm going to go ahead and hit save, and we're going to just go ahead and start a new scene. So we're just going to go plow through this, just, straight through. I'm going to jump in and create a new project in Houdini, in my Houdini folder called Pop Vortex Tutorial 3. This is, and just by habit, I always create a VDB folder. Not that we'll need one for this, but I just like to do that. And the reason that I'm doing number 3 here is because I created, 2 before. So actually, really quick, I'd also like to show you this rig because it's a very similar effect. So let's just hop out of camera and just press play. Whoops. So you can see that these particles swirl up, and we're actually using curl noise to color these particles entirely. And this one was a little bit more complicated. This actually used not only a custom rig, but I created all these custom settings just for this. And in Houdini, you can actually render your own geometry, and I turned this off later, but actually no, I didn't. It's right here. You can use your own custom emitter too. So it just swirls around, and you get this nice this vortex. And I think I actually have a setting to control the craziness of the oh goodness, what is it called? The curve. Actually, maybe I didn't. But anyways, it was fun. It was cool to create this, and let me see if I can pull up an example render. Open recent. That's what this looks like. So this was a lot of fun to make. Very, very beautiful, very powerful, very nice, solid movement. This one's a lot more chaotic because of the noise we're using, but this is basically what we're going to be creating. So let's just go back to creating that new project. Set recent project and create a new scene file. Make sure that we set that one more time. Set the project as Pop Vortex Tutorial 3. Accept it, and then save it. This is Pop Vortex Tutorial 3. Inside of its folder. Save. Okay, so the first thing we're going to do is we're going to start by creating a pop network. So let's go ahead and just hit Control and hit and drop a circle in. So if you haven't worked in Houdini before, this is probably not the first tutorial for you. but if you've got a little bit of experience jumping around the interface, or if you just kind of want to watch, this will be good for you to understand a few things about Houdini. So the first thing we're going to do is drop down this circle, and just because I like better geometry, I'm just going to give it a little bit more. I'm going to make it a little bit smoother, just for myself. And then we're going to add what's called a pop network, and we're just going to take this and plug it into the popnet. And again, for those of you that haven't used Houdini before, just hit tab and type popnet, and you'll get a pop network. And yeah, I think I'm going to keep it a little bit less simple than that moving forward. But anyways, what's going to happen now is all these particles are going to start to appear in that circle. So they don't move yet, but we'll control that. So basically, your particle object right here for your guides, your collisions, your physical settings for bouncing, friction, things like that, are all controlled here. If you want something with surface tension and viscosity, use a fluid network, flip fluid, but the popnet will work for now. And that's not the same way as working with this if you haven't worked with popnets before, but what you would do is use the particle fluid effects, and those are very powerful to help you get started. And then basically we take the source of this, and it scatters onto the surface of the first context geometry, which is this right here, this first input. We could use the second, third, or fourth as well if we wanted to. In fact, we could even create a number of different objects that feed into this. So if we wanted to do a grid as well, let's go ahead and get rid of the grid there and just put it in this. We'll rename this circle object 1 to particles, and we'll drop in, hit L, okay, and that lays it out. And we're going to create a grid, and we're going to put that into the source input of input 2, and scale it down just to kind of fit the size of the circle. So this is in input 2, and if we scatter onto the surface of the second context geometry and go back to the beginning, now these particles are simulating from the grid, so that's something you can do. But anyways, we're going to just go ahead and move forward now. You can scatter onto the surface of this object, and you can go to the birth settings and attribute settings to control a lot of things. If you want to inherit settings from this circle, then what you need to do is inherit those settings right here. Right now it's got an asterisk, which means it inherits all. That's just coding. Asterisk means it means all in I think C-based languages. And then you have your constant birth rate here, and the lifespan, variance, seed, things like that. Very useful for doing a particle simulation. So, and I seem to have, yep, okay, there we go. So, what we're going to do now is we've got our particles simulating, and we've got our solver right here. If we wanted to add some substeps, we can, and we'll want to do that later. But the next thing we're going to do is actually create a curve, and we're just going to do this in the particles node, and we're just drop in and create a curve and make that visible. And what I like to do, honestly, right here for Vortex is just create a custom node. So I'm going to do, a custom curve just by typing it in. So 0, 0, 0, space 0, 10, 0. And that basically gives you this. And that's got 2 points, one at the bottom and one at the top. And now what we're going to want to do to give it a little bit of variation, because I want it to curve around and be a little bit more noisy than that, we're going to resample it. So if we turn the points back on now, you can see that the sample is pretty dense. So we're going to set that to 1. And the next thing we're going to do is hit L and lay things out and create a point VOP. And what this is going to allow us to do is drop in and add a curl noise. And we're going to plug in the position. And what that's doing is it's taking the position of each of these points and applying that to the curl noise, which we can then plug in here. And that's not necessarily exactly how we want to do it. So what we're going to do is disconnect it and use what's called a float to vector, and plug that into the position for the output points. And I'm going to hit Control B here just to full screen this because this is all we need. Then we're going to use a vector to float, and we're going to copy that and paste it and pop it right here. So we're going to take the position and feed that into the vector to float, and the curl noise and feed that into the second vector to float. And we're going to feed the first and third values, the x and z values of the curl noise, into the float to vector. And what that's doing is it's taking the x and z positions affected by the curl noise and affecting them with the geometry, or excuse me, with the final output. And then we're taking the normal y position, and what that causes is this. And that allows us to push the particles left and right, and we can use noise to affect that. So I'm going to use, I think, sparse convolution noise. Actually, I might use simple noise. And I'm going to turn the turbulence down to 1 and set the frequency at 0.3. And the amplitude I'm going to set to 2. So this gives us a kind of jagged curve, but this is going to be a nice setting, maybe 3. A nice look. So the next thing I'm going to do is jump back up to the particles. We've got our point VOP set. Now we're going to resample again. And then we're going to smooth it. And to resample, we want to set it to 0.4. And with the smoothing, that's going to cause this smooth look. Okay. Then we're going to add a transform node, and that's going to allow us to move this around so that we can line it up with the z-axis. So let's push it back just a smidgen. Okay. And then also bring it down just a smidgen. Okay, so now basically the curve starts right there. And the next thing we're going to do is set the Vortex force attributes. So grab a Vortex force attributes node, and this one doesn't make a ton of sense if you haven't used Houdini before, but basically we're taking this curve which we've moved, and we're adding what's called a Vortex force attributes node to allow us to set the settings for the force which we'll use in here. So the vortex force needs two settings, or settings in 2 spots. So if I add a gravity force, you'll see that the gravity force is all set right in here. It's all in one node. You don't have to use a second node. The wind force, same thing, and we're actually going to leave that plugged in and set the velocity to 0 and the scale force to 2 to give a little bit of motion. Because we will be using that eventually. But all of those settings are in one spot. The vortex force doesn't work that way though, because we do have to have this curve. So it's kind of a catch system that allows you to work with that. So, and we'll set the we'll turn it on and set the lift to 30 and the velocity to 10. And we're actually going to change the radius in a bit using an attribute VOP. So the VOP network, as you can tell, I've already used twice, and we're going to use at least 2 more times after this, is kind of my best friend. So we're going to use what's called a bind and a bind export node. So we're going to set the input as, actually we're going to just use a bind export. So this is going to be setting what's called oh goodness, what's it called? Let's grab a vortex force in, and we can actually get it. So there you go. It's the orbit rad, because it's rad. The orbit radius. So the orbit radius is going to be set, and we're just going to delete the geometry output settings, by the position. So we're going to grab a fit range and drop that into the position, and drop that into the bind. And let's see, we want to use, you know what, we want to use the Y position. So we're going to get a vector to float, plug it in, and we're going to grab the Y position, and it's going to be 0 to 10, and 1 to 2 are going to be our settings. And let's try that. And we're going to now grab, so basically we've got it set up so that our radius is going to go, here let's explain that a little deeper. The radius is going to start at 0.0 and on the y-axis, and that's going to be at a radius of 1. And then it's going to get higher and it's going to get to 2. And I'm actually going to flip those and go from 2 to 0.5 for this case. And that's going to allow us to fit that in and bind that to this attribute. And the bind node is what's causing that attribute to apply to the vortex force. And basically this radius here is now being overwritten by this. So this will be the attribute VOP orbit rad. So we'll name it that just for cleanliness. And then we're going to make a null. Gotta spell null right. And we'll just lay things out again and rename this out curve. And we'll name it out vortex curve. Okay. And we'll hit C and color green. And we'll drop into the popnet. And basically we did all of that work and we didn't see anything happen yet besides this curve that looks nice and smooth and noisy. But what we can do next is create a SOP geometry node and route that straight into the vortex force. And we're going to go to the SOP path and set that to be the out vortex curve. And basically now we have our geometry setting along this axis at that angle. And our particles are going to be emitting off of this emitter right here. So I want to set this to be a little bit bigger. And now they are already following that curve because of all the settings we've set up. So the vortex force attribute has a 10 set for the velocity to spin, 30 for the lift, which causes it to follow the curve. And then we also have the the wind force to create the turbulence. And one thing I did in my original as well, by the way, that I haven't added here is that basically you can take this setting and multiply some curl noise, which you can just use the y-axis for that again. I'm going to skip that for this tutorial, but that created a little more variation. But in this case, I'm just going to try and keep this a little smoother. So we're going to want to set the minimum and maximum settings and adjust those a little bit. So what we're going to do is jump up and allow ourselves to set that. So we're going to set the minimum value and the maximum value to 1 and 0.25 and see how that looks. So that might be a little small. Let's go ahead and double that. So it'll be 2 and 0.5. So kind of within range of what we were doing earlier. So now the particles will come up and follow that curve. And I do want to make the radius a little bit bigger again. So now the particles are going to follow that curve. And they should stick pretty close to the center of that vortex. So you can see that the guide geometry is pretty accurate. Now, there's one thing you may notice is that these vortex guides follow the spline, and I usually really want that, but in this case, I do want to try and turn that off by taking the orbit or the orbital direction attribute, and instead of saying the orbit direction, actually we do want that orbit dir. Let's see if we can revert to defaults. Okay, there we go. Vortex force attributes, if you set the direction to 1, just 1 on the positive y-axis, basically now just by going to the vortex force attributes right here, you can set the direction. So basically that allows us to have these particles swirl and follow the curve, but they aren't having that swirling down below that was giving us a little bit of hassle earlier. So I can just cut this data type out and they'll follow the curve again, but I don't want them to follow like that right now. I want to keep them at this angle. So I didn't do that in the last tutorial, but for this case I do want to follow that. So And I'm going to add more particles so you can kind of visualize it better. And so basically, we can just uncheck show geometry at this point. The particles start to move up and follow it. They are affected by the wind source, or the wind force, excuse me. And they are subtly affected, but they are affected nonetheless. That's actually pretty strong. It's pretty good. It kind of gives this like realistic sort of feel. And if I just bypass that and start over, you can see that they're just following along, and they follow pretty well. But there is some issue. So let's go ahead and just get rid of the orbit direction attribute and see if that fixes it. Okay, it doesn't, but having the wind actually has been helping, so we'll just drop that back in. And we'll have it anyways, so that doesn't matter. So next thing we're going to do is, oh goodness, let's see. Let's look at my notes. Okay, we've created a vortex and a curve, a custom curve with VOPs and attributes. Now we're going to use VOPs and forces to create a nice swirling effect. So the next thing we're going to do is drop down a pop property, probably. You know what? Actually, we're not. We're going to use a pop VOP, and we're going to use this to create. So we're going to use a few of these. We're just going to separate them all. This one's going to be velocity, and then we're going to drop down another pop VOP. And this one's going to be called, let's see, scale. And we'll lay it out, and we'll create one last pop VOP. And this is in case we actually want to do this, but this is going to be called color. So the first thing to do is create the velocity. And this is going to be taking the velocity that it already has, and we're going to create some curl noise. So we're going to take the position, and this is going to help. We're going to help kind of influence that velocity. And we're going to just disconnect that. Okay. So this should help. So if we actually just go back to the PopNet and disable all of our forces, what you'll see now is these particles are going to follow along this curl noise. And the first thing we're going to want to do is make a few adjustments to it. I'm going to bring the frequency down because, frankly, I think that looks much better. And we can try a few different types of noise. I'm going to use simplex noise and see how that looks. I'm a big fan of the Perlin noise in this case, because I think it just has this nice kind of overall form to it. It's got this it's collecting itself almost and following these strands. And I like that. So we're going to turn the complexity or the turbulence down a little bit, and that's going to create a little bit more of a simple curve. And really that's all we need for this. The next thing we're going to do is set the scale, and we're going to do that based off of the velocity. And we're going to do a fit range, not unclamped, because we don't want it to go higher or lower than this. But first, what we need to do is allow ourselves to do this with a bind node and with a float. So bind export, and it has to be a float attribute. And what that means is that it needs to not be a vector. It can't be three numbers of x, y, and z. I need to be able to work with the average velocity of all x, y, and z. So I'm going to actually take a vector to float and an average node. And I'm going to take those, plug those in to the average node, plug that into the fit range, and set the output to p scale. And what happens now is we set our velocity to control the size of the particles. So basically you won't see that till render time, but we're going to set the destination max to 0.005, and those will be pretty small. So we'll hit Control B again, hit D, go to geometry, and I kind of want to turn these up a bit. And we could display these as pixels, as points, lines, disks. I actually think lines sounds pretty cool. I think that means that it follows its speed. So that's sweet. But anyways, we'll just use points and we'll set it to 2 or 3 for now. We'll set it to 2. And we're going to drop into the pop color and hit L and lay it out. And what we're going to do is take the velocity and plug it into the CD, just straight up. And what that does is it shows us the velocity is currently controlling, is now controlling the color. Oh, and one thing I need to do in the pop velocity really quick is set the offset to $F times, or actually divided by 2. And I'm going to just spread that across the board there for X, Y, and Z, and now that is going to offset the noise enough that we're going to get a little bit more variation there. It's not going to just follow one path, which I think looks better. And now we're going to go back to setting the color. Use a multiply node and get a constant node, and that constant is what we're going to use to add color. So we're going to multiply the color of these by our own color. And actually, I'm not going to use a multiply node. I'm going to use a mix node. Oops, that's the wrong one. We don't want to set the bias with that disconnected. Okay, so now the mix node is going to take that custom velocity, and we could actually use what's called a color correction node on the velocity and desaturate it 100%. And now that brightness is going to, actually, this is where we could use the multiply node. So we'll just plug this into the multiply node and try that instead. And basically, if we just, we might want to use a fit range as well. Fit. And we could use an RGB color and just say that we want the lowest value to be a little bit less dark. And this is a big mess, but what's going on is this right here. So now our colors are being affected by this fit range, and now we can set it to basically follow that. Another thing we could do is a ramp parameter, and I do want to try that actually. So what we're going to use is the we're going to use that velocity and multiply that by our own color. So what we're going to do is now take this default color and we're going to jump up to the popnet, and we're going to edit the parameter interface, and this is where it's going to get a little different, but it'll be easy. We're just going to set a color here. This is just going to be p color, or it'll be sw underscore p color, and this will be particle color tint, and then this will be we'll name this ramp. What will we name this? Velocity based color ramp, and this will be cool. A little different than our last render, or than any render actually. And we're going to just copy this parameter of this color, go to this constant node, and right click paste relative reference, or copied relative reference I think it is. And now we actually can control the color of the tint up here, and then we can also multiply our own colors on top of it. So a slower particle can be orange. Alright, and I'm going to actually just use white really quick. And then a faster color can be red or blue. We'll use blue. And as you can see, the particles are only getting about halfway through. So what I want to do is do a fit range. I'm actually gonna see. First thing I'm gonna try is actually doing the vector to float here. I'm gonna see if averaging all of these colors together would help, because right now I'm getting an output that I don't want. Whoa. Disconnect. Okay, can I just disconnect? Okay. We're just gonna shake this guy. Okay. And we're gonna just plug him in directly. Plug that into the ramp. And plug that fit range into the ramp. So now all these colors are coming in as a float, which is going to be basically clamped. So I can set my settings to basically allow me to, oh, that's the wrong direction. Okay. Allow me to create a little bit more contrast here. So what's going on is now my particles in this ramp are now being averaged, so I could technically not average them, but averaging them gives me a better, more accurate velocity average, and then it's taking that and fitting it in this range, then using the ramp to control those colors, and then I'm multiplying my color on top of that. So basically I can take my colors and create some fun looks with it. And you can actually use those bind settings as well to control the export, or excuse me, if you've ever seen a Mattias Muller animation, they're fantastic. And you can actually create a that sort of effect by using the bind export. So I could take, if we go to a material, just drop it in, we'll just rename this material particle material, and then we can take the emission value, enable it, and then we just reveal it, oops, by going in and copying the parameter and going to the popnet, going in, getting a bind export, and this color now is going to, we're going to take this, multiply this look that we have right here, and just hit paste. Oops, actually we want to paste the reference or the relative reference. Okay, so it's the emission color. And it might be a little bit more complicated than that, but we'll see if it works. And if it doesn't, we'll focus on how that works later. I know that you can check out a Ben Watts tutorial to see how that's done, but so if you need to figure that out, go ahead and check out his tutorials. But anyways, I'm just going to delete that for now. So we've got our particles colored, and they are animating, and I'm going to just turn that back off. Okay. And what we can do now is basically take our colored particles that are moving based off of curl noise, scaled based off of velocity, and colored based off of these settings, add some wind to them on top of that curl noise. So you have your initial velocity plus the environment wind, and then you take all of that and toss it into a vortex, and this is where things get fun. So we can take our vortex force attributes, or excuse me, our vortex force, and turn off the guides, and drop down and see how it looks. And one thing I'm going to actually adjust is I'm going to take this fit range, and I'm actually going to turn it into a, let's see, ramp parameter. And we're going to take that y-axis and just plug that straight in. Let's see. Okay. This is the... Okay. So basically what we're going to use now is this ramp right here is going to control our scale. So what we want to do is set it in here to be a spline ramp, and we can take our fit range, and we want it to, actually we want to go through the fit range for this, and we will just use this to control our settings right here. So they're really small, and that is because it's going from 0 to 10, and we need to delete these inputs and set them to 1 and, or excuse me, 0 and 1, and see how that works. And let's see if this fixes it. So basically what we're gonna, oh yeah, we need to make sure that we see our guide geometry. So now we have a linear curve, but if I take these and set them to B-spline, and if you give me just a moment, I'll show you what's going to happen. We'll now have this curve right here, and we'll take this value over here and turn it way up to 2. Actually, we'll leave it at 1, and then we'll take the fit range and take the destination max and set it to 2. And now we have this nice curve, and that's actually going the direction I don't want it to. I want it to be sharp in the other direction, so we'll have it be nice and sharp like this. So imagine this darker area, this background is going to be controlling the scale. So, and then we'll take the these minimums and maximums and output them again, and it'll actually be let's see. If we set it from 1 to 3, and gotta make sure that this ramp is working properly. Yeah, so basically what's happening is I set it from 0 to 1, and it just turns into the hard curve right there. So, sorry, that's a quick test. To make sure that this works, and let's go ahead and make sure we have a little bit more contrast in these. So the minimum and maximum values on the output should be controlled now. And I think the ramp is actually overriding that. So let's try this. So we set it from 1 to 2. And that's going from 0 to 1. So basically the ramp is going from 0 to 1, so we should set that from 0 to 1. Then fit that. Oops, let's do, we're going to use 2 fit nodes. So this is going to be 0 to 1 and then 0 to 10. So we're taking this value and mapping it from, actually what we need to do is map it from 0 to 1, or excuse me, 0 to 10. Here, 1 second. I'm going to fix this, then explain it. Okay, so now it's really strong, and the way that happens is basically I took this value of 2, and it cuts off right here. So that's because it's clamped. If we wanted to fix that, we'd have to use an unclamped fit range, but we can now control this setting right here, and the maximum value and the minimum value are controlled here, and we actually want to set those in reverse. So now we can set it like that, which looks really cool. And what's going on is I need to take the position of the geometry input, the curve, and it's going to take the Y position, fit that in. It's going to go from 0 to 10, which is bottom to top of the curve because we know it goes up to 10, and it's going to go from, and it's going to map that basically down to 0 to 1. Then we're going to use the ramp, which is 0 to 1 sort of setting. These positions right here, this is 0 and 0, so this is a 0 value at the 0 position multiplied by these, and then it's a 1 value at the 1 position, so that's not 10, that's 1. So we need to multiply that, so we need to take the y-axis and make the destination max 1, use the ramp, then we're going to take that ramp and invert it. So it's going to take the source, which was set from 10 to 1, and take that from 1 to 10. So So basically we're multiplying by 0.1, then multiplying by 10 to put it right back where it was. Then we're going to use the actual output source to use these minimum and maximum values, and those then set the orbit radius. So that is how we set that setting. And now these particles will follow up this curve nice and smooth. And this technically should also work, all of these settings, with, I don't know how you would use these. Actually, I know that you probably wouldn't use these. You could use the particle velocity to control. What I'm getting at is volumes, like smoke. This would also work with water, with a flip fluid simulation, but anyways, you can use like this vortex force attributes and the vortex force with smoke and create a tornado this way as well. But I've had a few issues with that, and I think the solution is just add a lot more sub-steps. But if you have any recommendations and you're watching this and you already know the answer, I would really appreciate your input on that. As to why it might, basically it will like have no velocity and then it explodes with velocity. So anyways, so we have our particles outputting and moving now, and it's pretty cool. So what we want to do is go back to the beginning and make sure that the velocities and everything just work. So we're going to actually use like a ridiculously small amount of particles. So we're just going to set it to 150. And again, we're going to take that guide geometry and turn it off for now and see how these particles flow. It's pretty natural, pretty cool, and I like it a lot. So if we just crank that number up, basically now what we would want to do is write it to disk. So the last thing we need to do is add some lights. So we're going to just do some rendering, and what I'm doing here is setting up a light, and I'm going to copy and paste it, move it around, then copy and paste the original light again, move it around, and what that gives me is, you guessed it, 3-point lighting. So now we've got these 3 lights, and I'm going to change the exposure to 1 and the intensity to 75. Turn off normalize and set the area size to 3. Set the look at transform for all of them to the particles, and we're great. So now we can render our particles, and I'm actually going to drop in a camera too. I always type it in. I never hit the shelf tool and hit control because the view focal length is set to 1. And if you've ever used a camera, you know that your focal length should never be at 1 millimeter and look that close. Basically, it changes the focal length and the aperture and the it changes the sensor size, and it causes quite a weird effect, and I do not like that. So we're gonna go back, grab that camera, and just pull out, and we're gonna hit render, and this is gonna give us our particles rendered theoretically, and they are really dark. So we're actually going to turn this brightness back up to 200 and set the exposure to 5. See how that works. Okay, so basically the scale of the particles is incredibly small. So some of those particles, if you recall, are very small because we control the scale based off of their average position, and we want to set the minimum size as well. So this is where things get fun. We can now set the particle scale based off of their velocity, so you can get a very nice, cool variation here. And they look sweet. So I don't know if I want that much variation, but back in the good old days, this is something you can do in X Particles, by the way, in Cinema 4D. But it's P-Shade, this shader for Cinema 4D was out a while back, and this is something you could do in there. And it was discontinued because it was integrated into X Particles, but it's a pretty cool look. So now we have these particles that come out and shape in this form, and we're having some fun with it. So I'm going to go ahead and just let it play for a second. And I'm going to pull the camera back so you can see it. And it's this nice turbulent vortex force. It's fun to make things like this. It looks cool. And these lift up, and they're pretty strong. I'm gonna full screen it. I'm gonna override the camera resolution and set it to half resolution. And I'm gonna set the depth of field, I guess, and the motion blur. And I'm gonna set this so that it is on scale, looking at the particles. Basically what I'm doing here is I'm setting the translate position to be directly in the z-axis, so it's not in the y-axis, and that gives me the ability to create a focus distance, and I can know what that is. And then I can create a null and plug that into the camera, and then I can just rotate that, and that's actually the wrong rotation value. I can rotate that now, but now I can always set my camera distance based off of this position. So if I want to change the position of the null, it's not hard. And I can reposition the camera based off of that. But now I always know, just through rotation of this camera and all these settings here, I know that the camera is 20 units away, so I can set my focus distance, and I can have like crazy depth of field. So, which is, if you are like me and you like having really awesome renders, that can be really fun. So I'm going to let this play for just a smidgen, and I'm also going to take the shutter time and use a quick expression. I'm going to do 1 divided by $FPS, FPS divided by, or times 2. So that's going to give me a 0.020833, and I'm going to change my FPS in my settings to 300. And now, basically, that's going to give me an even shorter shutter time. But what that is that's just a good healthy shutter. If you've ever worked in video or film, you take your frames per second, and if you just multiply your frames per second by 2 and divide 1 by that number, that gives you your shutter time, and that's a good healthy angle. So that should be 180 degrees right there. So now our particles are set, and I moved the camera, so I'm going to move it back. Let's just set these transform values to 1, 20, and move it in the non-traditional form, but it works because it fixes the focal depth problem. Okay, so I'm going to let this play for just a second, and then we will go ahead and do some rendering. Alright, so I've dropped out of the camera, and you can see that the particles are starting to move in their direction, and the curl is affecting them. So if we just hit render, we'll go ahead and let the particles form, and I'm actually going to just set the resolution to just be the native camera resolution, which is good. And then we're going to take the lights, which are kind of strong, set this down to 2, okay, and we're going to grab the material and just really quick, I'm going to make a few quick adjustments. I'm going to just set it to a very metallic reflection, turn the roughness down, and I'm going to go to the settings and set the IOR to 2.5 and leave it at that, and we'll see how that looks. Okay, looks pretty good. And now our problem is that the particles get too small. So let's go back to the particle scale here and set them to 0.1 and 0.05 should do, or 0.005. And now we have all of our particles. And if we make them just a little bit bigger at the max scale, basically we get this nice cool effect. You can tell obviously that it gets pretty blown out because of very bright lights. So we'll take these and drop the exposure down to 1. So the problem earlier wasn't the brightness of the light so much as the particles were having some issues because, well, they were too few. So this looks super cool, and the colors affect it as well. The pop scale, the velocity is controlling the scale. And actually what I want to do is I want to swap these, so it's going to be 0.2 and 0.005, and 2 is too large. We're going to do 0.1. Oops, actually 0.01. So if they're more static, they're gonna, maybe 0.03. The more static particles are gonna be larger, and then they'll move faster and they'll shrink. So anyways, they look pretty good. And what I was getting at is that these particles are going to have their scale and color be pretty similar because the color is taking, in fact, the velocity to color it. And we could use other things like curl noise to affect that. But anyways, this is really fun, really cool look. I'm going to turn the diffuse off and see how it looks with just the reflection. Okay, let's not use that. Let's just turn that to 0. Okay. So beats me, why? But these settings are not controlling the particles. You know what? Do you guys want to hear a funny story? I never set the material. So we're going to go to the shop network and create that pop material. And there it is. Pop. Okay, we're going to turn on the reflections and just start by solely reflecting it. And that's really bright. So we're going to use the point color again, turn off the base color, and we're going to turn off metallic reflections. And I'm going to set the inside IOR to 1.517 for glass. And that's really intense. So what we're going to do is turn down the lights, but first I want to turn down the roughness because I do want them to reflect pretty well. So back to the lights, set the exposure to 0 and the intensity to 100. And now these lights look way better. And we're going to turn the metallic reflection back up a bit. See how that looks? Maybe not, actually. Turn the roughness on just a smidgen. I want to keep it pretty low. So they're very reflective, very beautiful. A little bit more like that pink render I have. A little less like this. This is actually all refracted too. This is transparency, and it's very cool, very fun. So if we just hit Control B and let this render, you can see exactly what we've created. So yeah, we're going to go ahead and let this run for a little bit, and I'm going to show you how to write it to disk and how to bring it back in. And then we'll go ahead and add a lot more particles and let it run for a few frames and see how it looks in general. And have some fun with that. So let's go ahead and go back here, and we're going to drop into the particles. And we're going to start by taking a file node and write that into the PopNet. We're going to just turn off the rendering. Okay, the file node we need to select, and we're going to just let it think it's going to read files for a bit. We're going to go to the HIP folder, the Pop Vortex Tutorial 3 folder. We're going to go into the sim folder. We're going to name this Pop Vortex Tutorial sim01 _ frame dot $F, capital F dot sim. Okay, so what this is the name, which simulation I'm running, which revision, then the frame, and then the dot is just a cleanliness thing for me. We could also use an underscore or just nothing at all. I'm using the dot, and then $F is for the frame, and then the dot sim. And we're just gonna set it as a dot sim. Actually, I'm gonna set it as a BGEO file and hit accept. We're gonna write these files, and then we're gonna hit the blue flag right there. And what's gonna happen now is that these particles are going to play through, and they are now, oops, that's not it, writing to disk. Goodness, I can't even open this. Okay, so if we just pause our simulation, you can actually see that this is now, if we turn off show sequences as one entry, you can see that these have all been written. So we didn't even need to pause, that was convenient. Yeah, so basically, let's see how we're doing for time. Okay, the simulation looks really cool, looks really stellar, and again, we're out of camera right now. But what I want to try is setting the camera to a, let's see, -90. Let's see if that does it. Okay. Now the particles are going to be based off of 2 units of measurement above that point right there. And we're going to create a new camera and drop into it and set the rotation to 0 to reset the rotation that was having some difficulties. It was inverted, and it locks it into a certain place, and when you go to -90 perfectly, sometimes it'll invert the scene. But anyways, we've got the scene set up, and we've got some cool particles, and hopefully this has made a lot of sense for you. For those of you watching that haven't used Houdini before, ask lots of questions, and I'm going to try and make a lot more Houdini videos. I think it's really fun, really fascinating. I love this program. I have so much fun in it. And I'm also currently doing a lot of freelance work as well, so if anybody needs any contractors to help with things like this, you can hit me up and inquire about the project. And yeah, thanks again for watching. And check out thinkparticle.com for more fantastic tutorials, tips, and more great programming by myself. And we are going to have some more great tutorials, and we've got a lot of great products for those of you that use Cinema 4D, and we may or may not have some coming eventually for Houdini and other programs as well. And especially, side note, Houdini Indie version, which I use, is a lot of fun, great price. If you haven't used it before, pick it up from sideeffects.com. They have a free learning edition. And if you've already gone through this tutorial, you probably should know all of this. But some really exciting news is that the indie rendering support has just been announced. If you are watching this in a couple weeks, then it's already out. But at the end of May, I think it's the very end of May is when it is, yeah. Houdini Indie will start supporting RenderMan, Arnold, and Octane Render. And I'm a big fan of Arnold and Octane because I've used them for... Octane I've used for years, Arnold I've used for the last year. Very powerful. I highly recommend both. Octane's really fast, and then RenderMan is obviously fantastic, but it'll be great to be able to render particles like these in those settings. And I just had one more note. These particles look super cool. There's just one thing I would mention, and that's that if these particles don't seem to be following the whole height of the curve, and you are concerned about that, what you can do is change the force attributes to have the lift be stronger, and they should be able to hit the top range of the particles. So basically what's getting in the way is other forces are trying to take over, and it's competing. And of course, this is a simulation. You just basically what you're doing is convincing the particles to do what you want. They are not perfectly controlled to do every single little thing you want. unless you get that meticulous. This is a simulation, and when you use turbulent forces, which will make it look better in the end, that imperfection, which is actually a perfect replication of reality, allows you to get a much better look. But you gotta coerce it. You gotta tell it, hey, that lift isn't pulling you up high enough. Let's go a little faster. So that's one thing you can do. But let's go ahead and finish this, and we'll show you how to do the final playback once you've finished. And I just use the file node, and there's a particular method I use to move it over, because sometimes I move it over and forget to move it over in this manner, and it overwrites files and it causes problems. So if you know how to do that, don't worry about it. But we're just going to wait one moment more. I'm going to pause while we do these last 20 frames. Alright, so one thing you'll notice is that it's now on frame 128, and we're just going to stop it, and you'll think, well, Sam, why did it not go to the end? Why did it start over? That's because you're looping the playback. So one thing you need to do is, if you have a simulation going overnight, it's healthy to just, before you set it to go, set it to play once. So it's overwriting the files, but they're the same files, because this is an exact science. It is, the randomness is even, accurately, the same. So what we can do is just drop this file out. So what I did was I copied and pasted the file node. Oops, let's not do that. Let's undo that. Okay. Hit L. Okay, this is the write to disk, and then this is the simulation cache. And what we want to do, actually, we're just gonna grab this right here. We're going to grab a file node, and it says job, but I want to say hip, I think. And we'll just read the files and rename the node to simulation cache. And now these particles are simulated, and it's stored every bit of information, including the scale and the color, all in those particles. And what you could do next is you could do an Alembic export if you wanted to, and set the Alembic export to basically, let's jump back into our camera. Okay, so the Alembic export can then be brought into, say, Cinema 4D and used with Krakatoa or things like that. So lots of fun. So we're going to go back to our raw camera. Actually, we're going to leave it in that camera. And we're going to set up the final camera. Okay. We'll set the position of the camera to 2. And since we're just reading the particles, we can just see that that's already going to work. And they look fantastic. I'll just preview really quick and then render so you don't have all that confusion. And yeah, so basically now these particles are moving in this nice vortex force form, and it looks super cool, very powerful, and very customizable, incredibly directable. If you don't want them to spin around it, you can just have them follow the curve. And it's a lot of fun. So that's basically my video. So thanks for sticking with me for the last hour. For those of you that stuck around, I really appreciate it. And just drop me a line if you have any questions. So I'm Sam Booker with thinkparticle.com. These are some cool particles that look like kind of like a wizard's hat. And I'll catch you guys next time at thinkparticle.com with more training.